So over the past week I've been working on replacing all the aluminum bracket parts. So these are the original versions I made out of aluminum, cutting them by hand and basically drilling with a power tool. And the precision on these were pretty terrible. I had a lot of wobble and stuff. So I've now then replaced them with iterations of 3D printed parts. So these are some prototypes. They didn't work for various reasons. Eventually I have a fully working system. So there's one piece all mounted, ready to go. There's another piece, and there's the third piece, and this all works together for one axis of motion. The goal this week is to move it from one axis, adding basically 2 more motors to the system. Follow focus here, as well as the ability to adjust the zoom. So the first part of any project is measuring out the things and getting kind of a design laid out. So I have a sketchbook and I've been gathering precise measurements and entering into my notebook. From there I input it into CAD, and I'm still learning CAD. Inventor is the software I'm using. Inventor has a spur gear auto generation tool. You just enter some measurements and it will create the gear for you according to the specifications you enter. And then from there, I basically just drew a circle around the approximate diameter of the lens focus ring. Alright, so this is the completed gear. And so now it's a completed CAD design. I gotta export it as an STL file, which is something a 3D printing slicer program can understand. So I always export it as the highest quality setting. So then now from here, I open up Simplified 3D, which is the slicer program I use. Because this is a high precision part, I set the print quality settings to the highest, and I selected an infill of 100%. Because this gear is so thin, the amount of infill really doesn't matter, so might as well be all the way full. Now I'm going to preheat my 3D printer to the PLA because I'm going to switch out the filament, and also because I'm about to print. I was printing in a wood filament, but since I'm going back to working on the sliding rig, I'm going to switch it out with the black PLA I have here. It's pretty simple. Just let the nozzle heat up. So now I'm removing the wood filament out from the printer, and I'm going to swap it out with black PLA filament, which will look a bit nicer for the rig. I cut the filament strand at a 45-degree angle, so it makes it a little bit easier to place inside the printer. The angle basically makes it work like a needle. Alright, so I got my Raspberry Pi connected to my 3D printer, which is nice because I can remotely control it with like phone, for example. I'm gonna get rid of all the old wood filament out of the system and replace it with black. Now I clean the bed of the 3D printer and upload my G-code file to the printer. And like that, the gear is done, and it fit perfectly in the first time. The zoom ring on my lens is a slightly different diameter, so I'm going to have to make a second ring for that as well. I had some problems with the first print because I made the diameter too tight, which did not fit properly. So I used this ring as an opportunity to test how strong it is. As you can see, it's pretty strong. I designed a gear that would attach to the motor shaft and then attach to the focus our follow ring. Unfortunately, I had some problems with it not sticking to the bed properly, so I had to cancel out of that build. So I also needed to re-level my bed because it wasn't doing a good job printing. So basically how you re-level a bed is you place a piece of paper under the printer and make sure it's about a paper width apart, and do that for several corners. I also placed some masking tape on top of the bed so that it would help stick better. I used one of the failed builds to test out the diameters, and it seems to be working well. Printed another hub, and so that went pretty well. Unfortunately, my 3D printer also died and stopped powering on, and there seemed to be some sort of electrical problem, so I ran out to the hardware store to pick up a multimeter to help diagnose the electronics issue. Eventually figured out that the problem was a fuse that had blown. So on a multimeter, there's a thing that will make a beeping sound when it completes a circuit. And so I pulled out the fuse, and as you can see, it doesn't make a beeping sound. I had already had a problem with this before, so I actually bought the proper fuses from Amazon, and that's a working fuse. As you can see, when it completes a circuit, it makes a beeping sound. Also had noise in the fan, so I took it apart to basically realign the fan, and then I reassembled everything. Now it's time to design the bracket for the motors for the follow focus. This is by far the most complicated CAD design part of the project so far. It basically consists of a platform, which I'm designing now with a lot of curves and angles to get right, as well as a cut-in that has to go around a pipe. Bracket's the same as previous brackets I've done on the one-axis motion rig, but then it has to be expanded. Along the side, I have to add a cut-in for a nut and a bolt to go through so I can tighten it, make sure it's nice and snug along the rails. Drop it in Simplify 3D, which has it print off in kind of a weird angle thing, but it adds support braces along the side that will have to be removed later. Take the nuts and bolts and put it together, and a few screws mount the motor, and it seems to work pretty well. Friday I built nothing, but I went to a Sturgill Simpson and Willie Nelson concert, which was amazing.
In spite of his ways that she don't.
Finally got a Gorilla Pod tripod, which should help make things slightly better when rigging up the camera. Printed another bracket. Used a heat gun to help remove some of the stringiness that was on the model. Opened up a motor and assembled it onto the bracket using M3 screws. Hopefully next week I'll test this out and see how effective it is and do all the electrical work involved.